Let's identify our three key pieces of information. First, what are we given? The question states that we have 4.91 times 10 to the 23rd atoms of helium. Next, what are we asked to find? We need to determine how many moles of helium are present. And lastly, what do we need to get from one to the other? In order to move from atoms to moles, we will need Avogadro's number. That single conversion factor should be sufficient to solve this problem. We will always start our calculation with our given value. This means that we need to start with 4.91 times 10 to the 23rd atoms of helium. It will be placed in the numerator of our train track. Next, we will need to move away from the unit atoms and towards the mole. The mathematical definition of Avogadro's number is that there are 6.022 times 10 to the 23rd pieces per 1 mole of that sample. Since the definition states per 1 mole, the value 1 will always go with the unit mole, and the value 6.022 times 10 to the 23rd will always go with the descriptor for the individual particle. That's atoms in this case. Note that it doesn't matter what unit is used to describe those pieces, as a unit can change based on whatever descriptor best fits your sample. Since helium exists as individual atoms, atoms is our best descriptor here. Figuring out what conversion factor you need is the first step, but now we have to figure out how to use it. Again, we are moving away from atoms and towards the mole, so atoms will need to cancel. I cannot get that to work unless I divide by Avogadro's number. Doing so places the atoms in the denominator so it can cancel with the unit atoms given in the problem. This will leave us with an answer in moles. I caution you to ensure that you're plugging your exponential notation into your calculator correctly. I know it sounds silly, but at least half of the class probably isn't. Your calculator will have a button specifically for these exponents. Using that button takes care of the entire times 10 to the 23rd portion of this value. Don't type this in literally into your calculator without that button, as it tells your calculator a different set of operations and you won't get the correct answer. Both the number and the exponents need to be correct for you to earn credit for these problems. Our conversion factors will have at least 2 units associated with them, and as such, they can all be used multiple ways. In the last example, we divided by Avogadro's number to move away from the unit and towards the mole. Here, we will have to do the opposite. Identify your given quantity. Then, figure out what you're asked to find, which is molecules of sugar. Then, determine what you need to get from point A to point B. This again is Avogadro's number. Our calculation will start with the given quantity, or 0.0125 moles of sugar. Since Avogadro's number is a definition in terms of 1 mole, here we will need to multiply by Avogadro's number to place the mole value in the denominator. Otherwise, I can't cancel the unit moles and move towards molecules. Again, it doesn't matter what the unit used in Avogadro's number is. Sucrose is found as a collection of atoms, specifically a molecule. Dividing moles by Avogadro's number will give us a value in terms of molecules.